For this problem, notice that we have a problem similar to what we did before. Let me go back real quick. In this one, we had a partial sum, and it eventually ended at a 1 over 256. But notice for our problem, it keeps going on. So we have an infinite sum here. So we have a geometric series where the first term is 1, and the common ratio is a half, because we keep multiplying by a half. And the formula for the infinite sum of the formula for an infinite sum of a geometric series is a sub 1 over 1 minus r. And as long as your r is between negative 1 and positive 1, or in other words, as long as the absolute value of it is less than 1, then you can use this formula. So we would have 1 over 1 minus a half. 1 minus a half is a half. So 1 over a half is 2. So when you add 1 plus a half plus a quarter plus an eighth plus ... forever, your sum is 2. Now this should not be surprising to us, because if we go back per our previous discussion, we had said that this part here was equal to 1, clearly, and that if this sum was really close to 2, which it was, because we got 511 over 256, and I had mentioned that 511 over 256 is really close to 2, which means that this part here must be really close to 1, so that if we kept adding forever and ever, as we just found, our sum would equal 2. So as long as your common ratio is between negative 1 and 1, you can find the sum of a geometric series using that formula a sub 1 over 1 minus r.